Okay, this is number 22 from Are You Ready for Calculus? And we have this equation. This is kind of the general form. X squared plus y squared plus 6x minus 4y plus 3 equals 0. And they want you to find the center and the radius for this circle. So we put this in this standard form we talked about in the last problem. This form here, x minus h squared plus y minus k squared equals r squared. Then we'll have the center and the radius. Okay, so what we have to do is we have to complete the square. So what we do is we separate these out, so we put the x's together and the y's together. So this is what I did over here. And then just like we were completing the square in some earlier problems, what's half of 6? 3. And what's half of 4? 2. And we put the 3 over on the other side, so we have negative 3. So we isolated the x and y terms and put the x's together, the y's together, and then put the numerical term over on the right. And then we have to add 3 squared to both sides and 2 squared to both sides. And that's always going to be positive. So I add a 9 here, 3 squared, and I add a 2 squared. So I have to, what I do to the left, I've got to do to the right, so I add a 9 and a 4. So the right side adds it to be 10, and now this is a binomial square. And it's going to end up being x plus 3 squared. And this is going to end up being y minus 2 squared equals 10. And now that's your r squared, so the radius would be the square root of 10. And there's your center. Negative 3, 2. So just by completing the square, we can get that in that nice, I call it graphing friendly form. Sometimes they call it standard form. To be careful in the way they notate those things. Okay, then the letter B. Okay, find the equation of the tangent. Now they're assuming this is the tangent to the same circle, okay, at the point negative 2, 5. Now what you have to remember is if we have a circle and we have a line that's tangent to that circle, remember that a segment from the center of the circle to the point of tangency will be perpendicular to the tangent line. That's from geometry. A segment from the center of the circle to the point of tangency will be perpendicular to the tangent line. Well, in 22b, the point of tangency is negative 2, 5. And we already know the center. The center is a negative 3, 2. So we know that a point, if we take a segment and we draw it from the center to the point of tangency, then that's going to be perpendicular to the tangent line. So now we can find the slope of the tangent line by finding the slope of any line that's perpendicular to this line. So first of all, let's find the slope of this segment from the center of the circle to the point of tangency. So we just use our slope formula, and I could call this y2 and this y1. So 5 minus 2 over negative 2 minus minus 3, which is 3 over negative 2 plus 3 is 1, so just 3. So that's going to be the slope of the point AT, and that would be from the center of the circle to the tangent line, point of tangency. Okay? All right, then what I can do is just take the negative reciprocal of that to find the actual slope of the tangent line, because I know that this line is going to be perpendicular to the tangent line. Okay? Now I've got a point in the slope, so this is the point of tangency, and I've got the slope, so I just have to put this in. So this is my point, negative 2, 5, and this is my slope, because that's the point of tangency, and that's the actual slope of the tangent line. Remember, that's the negative reciprocal of, well, kind of like this line over here, pardon me. So this is my slope here, and in this case the slope was 3, and this slope was negative 1/3. It doesn't look like that, but that's kind of the idea. I didn't draw it to scale. I could have drawn it on a graph, and you would have seen it probably maybe a little bit better. Okay, but again, we've got a point, and we've got a slope, so we can find the equation of the line. So I just put that in my point-slope form. Y minus 5 equals the slope m times x minus negative 2, which is positive 2. So there's the equation of the line. I'll multiply it through by 3, put all my x's and y's on my left and the numbers on the right, and there's the equation of the tangent line. Oops, a little more room here. Okay, so again, multiply through by 3, add the x to the left, subtract, add 15 to the right, and there's your equation. Okay, so the main idea is you got to remember your geometry, and a segment from the center of the circle to the point of tangency will be perpendicular to the tangent line. So you can find that slope by using the negative reciprocal. You got the point slope, and you're done. Okay. And again, email me if I'm going fast on these or anything doesn't make sense, and I can run another video and kind of work it out for you step by step.